motion and its description. Hello student, you have must seen that number of things in motion. For example, car, bicycle, bus moving on a road, train moving on rails, aeroplanes flying in the sky, blades of electric fan and a child on a swing. What makes things move? Are all the motions similar? You see that some move along a straight line, some along curved path, some to and fro from the fixed position, and how and why these motions are different. Today, we will find the answer of all these questions. Myself, Dr. S. K. Singhal, and I am going to discuss lesson motion and its description. After completing this lesson, you will be able to know, explain the concept of motion and distinguish between the rest and motion, describe various types of motion, rectilinear motion, circular motion, rotational and oscillatory motion. Define distance, displacement, speed, average speed, velocity and acceleration. Describe uniform and uniformly accelerated motion in one dimension. Draw and interpret the distance time graph and velocity time graph. Establish relation between the displacement, speed, average speed, velocity and acceleration. Apply these equations to make daily life situations convenient and to explain the circular motion. So, we first discuss the motion and rest. You have observed a moving bus. What do you notice? The position of bus is changing with time. What does it mean? This means that bus is in motion. Now, suppose you are sitting in a bus moving parallel to another bus moving in the same direction with same speed. The position of the other bus with respect to your bus is not changing with time. In this case, the other bus seems to be at rest with respect to your bus. However, both the buses are moving with respect to the surrounding. Thus, an object is in motion can be at rest with respect to one observer, whereas another observer the same object may be in motion. Thus, we can say that the motion is relative. You can see here the example of the relative motion. One man is moving, another one is rest. So, the motion with respect to another man. Look the motion like the Chintu and Golu. Chintu and Golu are moving to the market, Golu is running and Chintu is walking behind him. What happened to the distance between them? The distance between the two will be going on increasing, though both are moving in the same direction. To the Golu, it will appear that Chintu is moving away from him. To Chintu, it will appear that Golu is moving ahead and away from him. So, that is also an example of relative motion. Consider another example. There are 5 players participating in 200-meter race event. They are running in their lane as shown in this given figure. The players A, B, C, D, E runs 2, 3, 4, 3 and 2 meter respectively in 1 second. Can you help the player to understand that which player is in motion with respect to which player and which player is at rest with respect to which player? We write our responses in the given table below. You can see this diagram. So, first we take from A. You can see for observer A, the player B, C, D are in motion because their position is changing with respect to them, and player E is in rest because their position is not changing. So, E is in rest with respect to A because the change in position of A and E is in 1 second is 0. Similarly, we can find for B, C, D. Now, you can see the different things that is in motion, a ball that is lying over the table on the surface, and you can see we drop a stone that is falling, that is in motion, a person is running on the track, all are example of the rectilinear motion, motion in straight line. You can see here the ball is rolling on the floor, and now because the position of the ball is changing with respect to the floor. So, this ball is in the rectilinear motion. Another example, the stone falling from a building and a runner on 100-meter race track. What is common about the motion in all these examples? The position of the moving object is changing with respect to the time along a straight line. This type of motion is called motion in a straight line or rectilinear motion. Now, we have circular motion. You must have observed the motion of the hands of a clock, motion of child sitting on a merry-go-round, motion of the blades of electric fan. In all such motion, an object follows a circular path during the motion. This type of motion is called circular motion. You can see this diagram, the merry-go-round, all the person are moving over circular track. Let us do activity. We have a body here, we suspend this body with a string with the help in our hand, Now, we displace the body on one side, we have hold this body connected with the string in our hand and we release it and observe the motion. Now, we put this body and we move in such a way and again observe the motion. Now, we just hold it. Now, observe the three kinds of motion. Let us discuss about the oscillatory motion. Have you ever noticed the motion of the branches of tree? They move to and fro from their central position, position of rest or mean position. Such type of motion is called oscillatory motion. In such a motion, an object oscillates about a point often called position of rest or equilibrium position or mean position. Can you think of other cases of similar motion in your surroundings? So, now we discuss about distance and displacement. Consider motion of an object. Point of start of the object is called origin, the point of destination is called final point, and the length of the path followed by object is called distance. There may be a number path between the point of start and the point of destination, hence the object may cover different distances between the same point of start and destination. The unit of the distance is meter or kilometer. Now, we see an activity in the figure. It shows an object that moves from point A to B along three different paths. Measure the distance travelled by the object along these three paths, and you can see that all the distances are equal in all three paths. In any motion, you will notice that the object gets displaced while it changes its position continuously. The change in the position of the object is called displacement. Now, you can see another activity and study the cases shown in the figure A, B, C, D, E. In each case, measure the distance and displacement and write their values in the given table below. You can see the first diagram, point A and B are marked and the body is moving from A to B. Now, the distance is equal to the length A B and displacement is also equal to A B. In second case, the body moves from A to B, then come to C. So, the distance is equal to A B plus B C, while the displacement will be equal to A C. In third case, you can see a body goes from position A to B and come back to the position A. Now, the distance is equal to A B plus B A, that is twice of A B, while the displacement is 0, because initial and final point is same. In fourth case, the body moves from A to B and then B to C. Again the distance is equal to A B plus B C, while the displacement is equal to A to C. In fourth case, you can see the body is moving over circular path along the circle. So, the distance is equal to the length of circle, while the displacement is the distance between A and B. So, we can fill all the values of distance and displacement that we have measured in these figures and fill in the table. Now, we discuss about uniform and non-uniform motion. The motion in which an object covers equal distance in equal interval of time is called uniform motion, whereas the motion in which the distance covered by an object is not equal in equal interval of time is called non-uniform motion. For the uniform motion of an object, the position time graph is a straight line, and for non-uniform motion of an object, the position time graph is not a straight line. So, we study the following graphs of motion and which object have uniform and non-uniform motion. You can see the graph A is a straight line showing that it is a uniform motion. Graph B is not a straight line showing that it is a non-uniform motion. Speed, now we discuss about it. The measure of how fast motion can take place is called speed. Speed can be defined as the distance travelled by a body in unit time. So, the formula of the speed is equal to distance travelled upon time taken. The SI unit of the speed is meter per second, that we write meter per second. Similarly, the other commonly used unit is kilometer per hour, and we can convert 1 kilometer per hour to meter per second, and 1 kilometer is equal to 1000 meter and 1 hour is equal to 60 into 60 second. So, by solving it we get 5 upon 18. So, 1 kilometer per hour is equal to 5 by 18 meter per second. Now, again we see an activity. The table gives the position of 4 bodies A, B, C and D after equal intervals of time such that 2 seconds. Identify the nature of motion of the bodies as uniform or non-uniform motion. And you can see in this table we have 4 bodies A, B, C, D, and the position at time 0, 2, 4, 6, 8 seconds are given. At time 0 position of A is 0, at time 2 second it is 4, at time 4 second it is 8, at time 6 second it is 12 and at 8 second it is 16. Similarly, You can see the position of all the bodies that are shown in the table. Now, we identify the nature of motion, we can make a table as given below. For body A, the distance covered in first 2 seconds is 4 minus 0, that is equal to 4, and the distance covered in next 2 seconds is 8 minus 4 is also equal to 4, and distance covered in next 2 seconds is 12 minus 8 is also equal to 4, and the distance covered in last 4 seconds again to 16 minus 12, that is equal to 4. So, you can see the distance covered by A in all 2 seconds are equal. Similarly, for body B, the distance covered in first 2 seconds is 8 minus 0 is equal to 8, and next 2 seconds 8 minus 8 is equal to 0, next 2 seconds 10 minus 8 is equal to 2, next 2 seconds 12 minus 10 is equal to 2. And for body C, it is in first 2 seconds 8 minus 4 is equal to 4, next 2 seconds 12 minus 8 is equal to 4, next 2 seconds 16 minus 12 is equal to 4, and last 2 seconds this is 20 minus 16 is equal to 4. And for body D, the distance in first 2 seconds is 8 minus 4 is equal to 4, next 2 seconds 12 minus 6 is equal to 6, next 2 seconds 16 minus 12 is equal to 4, and last 2 seconds 20 minus 16 is equal to 4. So, from the above table we can conclude that the body A and C travel equal distances in equal interval of time. So, their motion is uniform, but the distances travelled by the body B and D for equal intervals of time are not equal, hence their motion is non-uniform motion. So, to analyze the motion as uniform motion or non-uniform motion, the motion can be represented by a graph. The position time graph of all 4 bodies A, B, C, D are shown here. Now, you can see that the body having the uniform motion A and C have their graph line straight. The bodies having non-uniform motion do not have their position time graph straight line. In this graphical representation, on the x axis we have taken 1 division is equal to 1 second, and on the y axis 1 division is equal to 2 meter. Now, you can see the graph of A is coming straight line, and graph of C is coming straight line, and graph of B and D are not straight line. So, you can see we can conclude about the motion of A, B and C, D. Now, you can see the graph, a graph drawn for the different distance travelled by the object with respect to time is called distance time graph, that is shown here in figure. Distance travelled in the 10 second is 22 meter. So, therefore, the speed of the object is equal to distance upon time, 22 upon 10 is equal to 2.2 meter per second, and the speed is calculated by the slope of the graph. The motion can be represented by another way. Speed is equal to AB upon OB, that is the ratio is known as slope of the graph. Thus, the speed is the slope of the position time graph. Now, see an example. An object moves along a rectangular path of side 20 meter and 40 meter respectively. It takes 30 minutes to complete 2 rounds. What is the speed of the object? Let us find. The distance travel per unit time is equal to 2 into 2 into 20 plus 40 divided by the time, that is 30 into 60, that comes 4 by 30 meter per second. Now, we discuss about the velocity. Velocity is the ratio of length of the shortest path, or we can say the displacement to the time taken. So, velocity is equal to displacement upon time taken. The velocity has same unit as the unit of speed, such that meter per second SI unit or kilometer per hour. The shortest path or the displacement is directed from initial position of the object to the final position of the object. Hence, the velocity is also directed from initial position of the object to the final position of the object. Thus, we can say that the velocity has direction. Speed does not have any direction, because it depends only the total distance travelled by the object irrespective of the direction. So, the quantities which have direction are called vectors, and which do not have direction are called scalar quantity. Now, we have another activity. We observe the motion of an object in the following situations, and we find the speed and velocity of each situation and comment over the situation which you will find different from other. You can see here the object A moves from A to B in 10 seconds, and we have taken a scale 1 centimeter is equal to 10 meter. Then another case, you can see the object move from A to B to C in 10 seconds, and the scale is 1 centimeter is equal to 10 meter. In third example, you can see the object move from A to B and then to C in 20 seconds, the scale is 1 centimeter is equal to 10 meter. And in the last example, you can see over the circle, object complete the circle of radius 7 meter in 10 seconds. So, we can find average speed and average velocity. The speed during a certain interval of time cannot be used to determine total distance covered in the given time of the journey and also the time taken to cover the total distance of the journey. It is because a body does not always travel equal distance in equal interval of time. In most of the cases, the body travel non-uniformly. Thus, in case of non-uniform motion, to determine average speed is quite useful. The average speed can be determined by the ratio of total distance covered to the total time taken. So, we have the formula of average speed, that is equal to total distance covered upon total time taken. Similarly, in case of average velocity, in place of total distance covered, we can use the total displacement. So, the formula of average velocity is equal to total displacement upon total time taken. Now, we discuss about the graphical representation of motion. It shows the change in one quantity corresponding to the another quantity in the graphical representation. So, first we have position time graph. It is easy to analyze and understand the motion of an object if it is represented graphically. To draw a graph of motion of an object, its position at different time are shown on y axis and the time on the x axis. For example, position of an object at different times are given in this table. You can see the table. We have the time, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have the position on the given time that are given here 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 meter respectively. In order to plot the position time graph for each for the data given in the table, we represent time on the horizontal axis, that is x axis, and position on the vertical axis, that is the y axis on the graph paper. Next, we choose the suitable scale. For this, the graph obtained is shown in the figure. You can see the graph. For good understanding, we can study the following graphs. You can see the distance on this y axis and time on the x axis. Here also we have the graph, that in graph first is a straight line. So, it is showing the uniform motion. Graph V is parallel to the time axis, that means the position is not changing with time, that is showing that object is in rest. And graph 3 you can see the position time graph is curved, showing that the rate of change of position is increasing, that is the non-uniform motion. And fourth graph also you can see the position is changing with time, that is not uniform, it is also non-uniform motion, rate of change of position is decreasing in this case. Now, we have another graph that we call velocity time graph. So, take time on the horizontal axis and velocity on the vertical axis on the graph paper. Let one division or horizontal axis represent 1 second and one division on the vertical axis represent 10 meter per second. So, plotting this table gives us the graph as shown in figure. So, the table given us the time 0, 1, 2, 3, 4, 5, 6, 7, 8, and we have the velocity of body A, that is 0, 10, 20, 30, 40, 50, 60, 70 and 80, and the velocity of body B we have 0, 10, 10, 10, 10, 10, 10, 10. So, if we plot the graph, you can see the graph of body A is coming in straight line, while because the position of body B is not changing with time, its graph comes parallel to the time axis. So, line OR and PQ represent the motion of object A and B respectively. So, we see that the velocity time graph of motion represented in this table is straight line and parallel to the time axis for B. This is so because the velocity is constant throughout the motion is uniform. Consider the area of the graph in the given figure for the object B. Area, that is equal to, for graph V is a length into breadth, that is 8 second into 10 meter per second, it is 80 meter. That is equal to the displacement of the object B in 8 second. Let x is the displacement of the object in time t moving uniformly, then this is x is equal to v into t for uniform motion. Now, we discuss about the acceleration. The change in velocity with time is called acceleration. Thus, the acceleration of an object is defined as the change in velocity divided by the time interval during which this occurs. So, the formula of acceleration is equal to change in velocity upon time taken. Its unit is meter per second square. It is specified by direction. Its direction is along the direction of change in velocity. Suppose the velocity of an object changes from 10 meter per second to 30 meter per second in the time interval of 2 seconds. So, the acceleration A, that is equal to change in velocity upon time, that is 30 minus 10 divided by 2, that is equal to 10 meter per second square. This means the object acceleration is in the plus x direction and the velocity increases at the rate of 10 meter per second in every second. If the acceleration of an object during its motion is constant, we say that the object is moving with uniform acceleration, and the velocity time graph for such a motion is a straight line inclined to the time axis. For the given time interval, if the final velocity is more than initial velocity, the acceleration is positive, that you can see in this graph. If the final velocity is less than the initial velocity, the acceleration will be negative, and that is called retardation. When the velocity of the object is constant, acceleration will be 0. Thus, for uniform motion, the acceleration is 0, and for non-uniform motion, the acceleration is non-zero. Now, we discuss about some equations of motion. Consider an object moving with uniform acceleration a. Let u be the initial velocity at time t is equal to 0, and v is the velocity at time t. S is the displacement during this time interval. These are the certain relationship between these quantities. So, to find it, so we know the formula of acceleration. A is equal to change in velocity upon time. So, A is equal to v minus u upon t. If we multiply, we get v is equal to u plus a t, that is the called first equation of motion. We can also find the second equation by knowing the formula displacement is equal to average velocity into time interval, and average velocity is equal to u plus v upon 2. So, S is equal to v plus u upon 2 into t. So, that is equal to u plus a t plus u upon 2, and that is equal to u t plus half a t square. This is the second equation of motion. We can also obtain third equation of motion using the above two equations by eliminating the time between them, and we will get v square is equal to u square plus 2 a s. In case of motion under gravity, the acceleration a is replaced by acceleration due to gravity small g. Now, we discuss uniform circular motion. You may have seen the motion of the bicycle on a straight level road. Now, look at the wheel of the bicycle. Any point on the wheel of the bicycle always remain at constant distance from the axis of the wheel and moves around the fixed point, such that the axis of the wheel, on the basis of the description of motion of the wheel, you can decide the very obviously that this motion is circular motion. You can see here the wheel is moving and this motion is circular motion. Similarly, can you think about the motion of the flywheel of the bicycle during non-pedaling? There is no circular motion of flywheel and it moves in a straight line. Thus, its motion is rectilinear motion, but during the pedaling its motion is circular motion. Can you think about the motion of any part of the bicycle which has two types of motion at the same time? Yes, during the circular motion of the wheel or flywheel, they are also advancing in forward direction on a straight road. Thus, their motion is circular motion as well as rectilinear motion at the same time. Now, consider the motion of an object along the circular track of radius r through 4 point A, B, C, D on the track as shown in figure. If the object complete each round of motion in same time, then it covers equal distances in equal interval of time, and the motion will be uniform circular motion. Since during this motion equal distance is being covered in equal interval of time, therefore, the ratio of the distance covered to the time taken, that is called speed, will remain constant. It means in uniform circular motion speed remains constant. Now, let us summarize what we have discussed today. First, the position of an object does not change with respect to time to a stationary object at rest, then it is said to be in rest. If the position of object changes with respect to stationary object at rest, then it is said to be in motion. When the object moves over a circular path with constant speed, its motion is called uniform circular motion. When an object moves to and fro about a fixed position, its motion is called oscillatory motion. The length of path followed by an object is called distance. The shortest distance between initial and final position is called displacement. The distance covered per unit time by an object is called speed. The displacement covered per unit time is called velocity. The rate of change of velocity is called acceleration. The negative rate of change of velocity is called retardation. The motion in which an object covers equal distance in equal interval of time is called uniform motion. The quantities which have direction are called vectors and which do not have direction are called scalar quantity.